All right, we're now going to do a quick concept check. We've had one video in between our general result and this one, and we're going to see how well you remember what you just saw earlier. When we looked at common families of functions, the two families we looked at were e to the kt and their integrals out to infinity, as well as the integral from 1 to infinity of 1 over t to some power. And we found some general rules for that. In general, what we said was the integrand has to go to 0 for the integral to converge. Fair enough. So it only makes sense to talk about the area being finite so long as the area or the function goes down towards 0. But it has to go down towards 0 in a very specific way. It has to actually approach 0 faster than the boundary case that we found for the natural family here, faster than 1 over t. So your challenge for the next second is to look at this integral and ask yourself, just by inspection and by remembering the rules that we saw earlier, will that integral converge or diverge? I'll give you a few seconds for that. Okay, so this exponential to a negative power, that was the easy family we found. This always converges for any negative k. So as long as we have any exponential decay, exponentials will always approach 0 fast enough so that the integral will converge. Let's take a look at the second example. The integral of 1 over t squared, does that converge or diverge? All right. One of the ways to think about this is to talk about that 1 over t graph, which is sort of the boundary case, 1 over t, and think of the kinds of values of t we're talking about here. We're talking about 1, and we're talking about 2, and 3, and 4. If we talk about 1 over t squared, that would be 1 over a quarter instead of 1 over a half, 1 over a ninth versus 1 over 3. So it's going to be a graph that approaches 0 faster than 1 over t. These values get smaller faster than 1 over t, and this is also corresponded to our k here being 2. The k was larger than 1, and so this converges as well. One more example. 1 over the root t. We know the function goes to 0, but what about its area, the area beneath that graph? Similar logic, different outcome in this case. We have the 1 over t graph, and then if we think of particular values, 2, 3, and 4, by the time we reach 4, 1 over t is at a quarter, but 1 over root t is only going to be at 1/2. So that graph goes towards 0, more slowly. It takes a more scenic route to get down towards 0 than 1 over t does. And that means its area is going to be larger, and so it's going to end up having an infinite area, just like the graph of 1 over t's area is going to be infinite when we go and push the boundary out that far. So this would diverge as an integral. So those are the kinds of things that we expect you to be able to show through calculation or simply use in particular instances. So these are common rules that we'll see just as a quick check and rules of thumb out of this analysis of families of functions.